నేను పైకి వెళ్ళి మిగిలిన సెట్టింగ్స్ నేను చూసుకుంటా.
నీకు ఎట్లా పంపాను?
నాకు హెల్లో లాగిన్
హలో గ్రూప్ లో మెసేజ్ వాట్సాప్ మెసేజ్ లేదు. ఎప్పుడు పెడతావు?
ఇప్పుడు పెట్టేస్తా, మన షెడ్యూల్ టీమ్ లో పడేస్తా. వెళ్తుందా? ఓకే. ఇది వస్తున్నాయి. ఇది
అవసరం లేదు ఇక
అక్కర్లే ఇంకా.
అవునా?
అక్కర్లే ఇంకా. సరే నాకు వచ్చేసింది. అది జస్ట్ ప్లే అవ్వడానికి నేను చూస్తున్నా. ఫస్ట్ నడుస్తుంది.
స్టాప్ కూడా కొడతా ఏది ఇదా? మీ అబ్బాయికి స్టార్ట్ అయ్యాలి. కొంచెం 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 ఎనఫ్ ఎనఫ్. అది డౌన్ చేస్తాను, అది కూడా డౌన్ చేయమని. Right. Good morning, guys. Good
morning, sir.
Morning, sir.
Morning. Yes. You are seeing my screen, right? Online?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So, last time we shared a Google file, right? So that one. So few people are asked, they have doubts in Python. So in Python, mostly few students raised EDA problems and this pandas, how to solve this pandas and how to solve this EDA. Okay. So as a data analyst, first thing is using Python. If you're selected as a data analyst with Python, so Pandas is the most important one. We can do our manipulation. We can do our extracting data. So everything with Pandas only, right? There is no another option to load the data into Python. Okay. There we have Polars, but right now no one is using Polars. So Pandas is very trending. Using Pandas, you can load your data into Python and you can manipulate your data, right? And after that, we have visualization tools, visualization libraries. So those are all my Matplotlib and Seaborn. Okay, so these three libraries are very, very important as a data analyst in Python. So using Excel, you can do this all analysis, right? And using Power BI, you can do this everything. Okay, and using Tableau, you can do these are all things. But in Tableau, manipulation is not possible. Complete manipulation is not possible. You can take the help of another tool. Okay, that may be SQL or Python or anything it may be. Okay, you can take different things help. So those things are possible. Next, So you can load data using Pandas in Python, right? So how we can load data? Suppose I have Excel data. How can we load into Python?
Then the name of the file and this file and that Python file is in the same folder. We don't need to give the location or the path. If it is not there, then we have to mention location as well. And in the end, again, dot CSV or Excel, whatever it is.
What is the extension for Excel?
Excel.
Excel?
Excel.
No.
Excel.
Not XLS.
Sir, XLSX.
Yeah. So XLSX. So XLS is old version, that is 2007 Excels, old Excels, that is okay. So from 2011, it is XLSX. Fine. So some files we have 2007 files, that is that files contain XLS only. Okay. At the moment, you can go with XLS, but now it is XLSX. Fine. So that is extension for Excel. So must and should you need to remember that one. Next, we have, suppose we have CSV file. So read underscore CSV, open bracket, and give your path and dot CSV, file name dot CSV. That is your CSV extension. So you can give that path and you can load into you can load your data into Python, right? So I have a Excel file that is a smartwatches file, smartwatch Excel. This is file name. So this is my path and XLSX I'm using. Okay. So pd dot read underscore Excel and path file name dot XLSX, right? Using this one, I'm loading my data. So I'm taking sample 10 records. Okay.
So what is that R there?
This is reading.
Okay.
File reading. So we have reading and writing. So W means writing. So that is file handling, not required for you. Just reading, read the file, read the path. Okay. If both are in same location, you no need to use R. So directly you can give file name dot XLSX. Fine. So now we are using path. So that's why I'm giving R. So it means read my path. Fine. So it is reading my path. So file name dot XLSX. I'm taking sample of 10. So only sample means one record it will provide random. Okay. Random one record, any record from your data. I'm taking 10 records. So randomly it will select any 10 records. See 442, 33, 97, 91, any 10 records randomly. Fine. So I'm running my all libraries. Next. Yeah. So I got my data. Randomly 10 records, 323 and 50, 340, 138, 261, like 10 records I got here. Okay. Next. So anyway, I got my data. I want to know how many rows and how many columns I have. Okay. How many features and how many records I have. I need to know, right? So for that matter, we can use shape. Okay. df dot shape, your variable dot shape. Fine. So 450 by 8. So here my 450 is records and 8 is features, right? Rows and columns. And next we have descriptive statistics, right? So what is my data? How my data is varied? What is the distribution of data? What is Q1? What is Q2? What is Q3? And what is the minimum value, maximum value? Okay, standard deviation and count, everything you can find using describe, right? So this is for only numerical data. We know that, right? Describe will work for only numerical data. Okay, see, I'm running my code. See, so serial number, it is a numerical only. Current price, discount percentage, rating, number of ratings. So these are all my numerical data. So that's why I'm getting count, mean, standard deviation, and minimum value, maximum value, 25th percentile means it's a Q1, right? Automatically it's a Q1. Next 50 percentile, it is Q2, right? And 75% it is a Q3. Fine. So you can do like this. Fine. So this is my only numerical data analysis. Suppose if you want to perform text data analysis, you can do include is equals to object. Then you will get object data type. Okay. See here, brand is object and original price is object and model name is object. So total count is 450 and original price 450 and model name 415. So it means in my model name, I have null values, right? So that's why my count is low. Okay, so it is completely 450 by 8. Okay, so here it is 415 only it is showing, means I have 35 null values, right? And it is unique values is 18 in my brand, and in my current original price 189 unique values is there, and in my model name 389 unique values is there, right? So this is your analysis. How many unique values is there? And top one, so Firebolt, and here 1799, and so Best Pro, right? So Beast Pro. So this is my top brands. It means high frequency, right? See here, it is 60 and 20 times it is repeated and 5 times it is repeated. So this is high frequency. Okay, so this is top one. So how many times it is repeated? 60 times. How many times it is? 20. It is 5 times. Right? Why? Because I have 389 unique values here. So that's why 5 is the maximum one. Okay, so this is your object data type. So normal describe means you will get numerical data. Simple. So here also you can see 450, 440. It means 10 blank values I have. Some blank values, and some here, some here. Okay, so mean value for everything 12,747 price is the minimum mean value, average value. Okay, discount percentage is 48 is the discount average, and ratings is 4.03 is the average rating. Okay, and number of ratings is 11,594 is the average. Fine. So standard deviation and minimum value is 1199 and minus 79 and 1 and 1. Rating is the minimum is 1 and number of ratings minimum is 1. So 25th percentile Q1 and Q2, Q3, right? And the maximum value is, okay. So 1,39,990 is the maximum current price, and discount percentage is 91% discount is the maximum. So rating 5 is the maximum, and number of ratings is 6,19,130. Yeah. Not 0, it is O. Yeah. Just now I explained, right? Oh, objects. Okay. Include O means include object data types. Fine. Here we have only integers, floats, and objects. Fine. 3 data types only we have. So objects means my string data. Fine. Yeah, that is. Info.
So when will you include only the string or wherever?
Only objects.
Only objects.
Yeah, only objects you will get. Right. So numerical and objects, it's not possible. Right. For numerical, you have mean, max, and so these things you have. For objects, you don't have maximum, you don't have minimum, and these kind of things. So, hello. Okay. Fine. So next info we have. Info means information about your data. Okay. So how many features I have, and what is the feature names, and what is the data types, how many null values I have, and how many rows I have, how many columns I have, and how much memory it is occupying. Okay, and how many float values I have, how many object data types, and how many integers. So everything information about your data set, right? Suppose you have big data set, okay, 50,000 or 1 lakh or 20 lakhs of records is there. So how much memory it is occupying, right? So this is your interview question. How can you find the memory space? Okay, how much space your data is occupying, right? So for that you can use info. Okay, I loaded my data, smartwatches data. So how much space it is occupying? It is 450 rows and 8 columns. Okay, see, when I'm doing df.info, so it is giving total 450 entries or 450 records or 450 rows. Okay, and that is 0 to 499. Okay, index value is 0 to 499. And next I have columns, total 8 columns I have. Okay, so that column names 0, 1, 2, 3, 4, 5, 6, 7, and these are all my column names, and each column description, it is 450 non-null values, and it is integer. Okay, here 450 non-null, it is object brand, and 440, 450, 377 some data, and it is object, and it is float, and it is model name is object, right? So how many float values I have? Total 4, right? 1, 2, 3, 4. 4 floats, integers 1, and object data types is 3. Okay, so like this, it will give information about your data and how much memory it is using. 28.3 KB of data. Why? Because it is a very small data set, 450 and 450 by 8. Okay, very small data. So that's why it is 28.3. Suppose if that is 10,000 rows or 20,000 rows, maybe it is 600 KB, 500 KB kind of thing. If that is 1 lakh or 2 lakh rows, that is maybe 1 MB, 2 MB data, right? So based on your data, based on your rows, so it will give that memory space and everything. Fine. So that is information about your data. Everyone understood? Info? Yeah. So
like price also is showing object data.
yeah, we have dollar symbol, right? We have dollar and we have comma. So those things we have. So that's why it is showing us object. Fine. Next, data types you can find like this dot d types. Okay, your variable dot d types. Okay, you will get the data types of each column. Okay, each column data type you can see. Huh? Inferential, yeah, that is inferential statistics. So that is testing and probability. Those all comes under inferential statistics. Okay, this is information, just info, inferential status. You can call it as inferential also. Okay, about your data complete. Okay, so this is descriptive, descriptive statistics, describing about your data. Next, D types. So data types of your data and how many unique values you have. Okay, so like this, it will give unique values for numerical and text. Fine. See, for each column, I have these many unique values. So serial number, it is the index value. So 450 means there is no duplicates. All are unique. Next, brand, 18 brands are unique. Okay, total I have 18 brands in my data. 164 unique current prices I have, and 189, 271, 27. So different things. Fine. So this is unique. So my method is variable dot n unique. Okay, so it gives number of unique values of your data. Okay, each column unique values it provide. Okay, next. So is there any null values? I want to check. Okay, anyhow it is giving here. Okay, here you can see, and so here you can see. So everywhere you can see how many null values you have, but column wise the sum of null values we need to know, right? So for that we can see your variable dot is null. Okay, is null. I'm asking question. So in strings we have is upper, is lower, is identifier. Okay, so same like here also we have is null. We are asking question, right? So if that is null, it gives yes, it is null. Okay, so without sum you can do. Okay, see, false, 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 true, false, true, false. Okay, see, it is true, it is null value. It is also true, it is also true. See, these are all true values. So here I have null values, right? But you can't, how can you understand how many null values I have in my data? You have 450 rows, right? So you can see only 10 rows or 15 rows or 20 rows, but you can't see the entire data. So, yeah. Which one? Uh-huh.
How do we know?
Yeah, must answer. Okay, so only shape we don't have parentheses. Okay, remaining all methods. Huh? Yeah, D types. So if you give D types, you'll get it. Okay, only few methods we have D types and shape. Okay, only few methods we have without parentheses, but remaining all methods and all functions and everything will accept parentheses bracket. Okay, where it is? Yeah, here is null means it is giving true or false. So we don't know how many values we have, what is the sum of null values, we don't know. So for that matter, you can use sum. So in my current price, I have 10, discount percent 73, 59, 35. So this is a count, okay? Sum. So total sum of null values, count of null values. How many null values I have? Fine. So like this way, you can find null values for each column, okay? Count of null values for each column. Fine. So this is just basic. So after loading the data, you can do this shape. Okay. After getting shape, so you can do this analysis. So head you can perform df dot head. Okay. Df dot tail, df dot head of 10. So first 10 values you can see, df dot tail of 10, last 10 values you can see. So those are all very common things, right? So after that, describe. So about your data, descriptive statistics, mean, mod, sum, and maximum value, minimum value, right? So 0% value and 100% value and 25% value, 50% and 75% value. So all values you can see in your describe, right? So inferential info you can do. So everything you can get. Fine. So that is inferential statistics. Huh? Which one? How much percentage? Yeah. So for that, maybe normalize it works. No, it is not giving. You can do manually, you can perform. So some it is not accepting normalize, and is not also, those are all methods it is not accepting normalize. Okay, like this you can find your null values. So sum of null values you can find. So next, so these are all basic steps only. Okay, these are all very basic steps. Unique values finding, null values finding. Okay, so these are all very common. Head, tail, sample, right? Next, so this is only data loading, and after data loading, some statistics. Okay, some statistics you are performing, right? And next you have data manipulation. Second step. Okay, adding new columns, adding new rows. Okay, removing columns. Fine. So those things are possible here. Removing rows, drop now we have. So and drop something we have. Those things we have. So those things are possible here. And greater than 500 and equals to 10, equals to less than 10. So which one you want to perform those things you can do here. Fine. Next. So here we have axing the data using different methods. So you have regular slicing method, and you have LOC method, you have ILOC method. Okay. So these three methods we have to slice your data. Okay. So what is the difference between these three methods? Anyone? Okay. Huh? Right. Next. Yeah. So normal slicing. Anyone online? Difference between regular slicing and these two slicing methods? This is also range. Yeah, label slicing. Okay. In LOC, in regular slicing, column slicing is not possible. You can slice only rows. Okay. You can slice only rows with all columns you can get in regular slicing. But coming to LOC, you can slice your rows and as well as you can slice your columns, right? And coming to ILOC, you can slice your rows and as well as you can slice your columns. But what is the difference between LOC and ILOC? So in in LOC we can pass label names, right? Column names we can pass, and you can reorder your data set. Okay, so which order you want, you can reorder your data set. So how many columns you want? Suppose you have 20 columns, but you don't want 20 columns to analyze your data. you want only 5 columns. So you can take the help of LOC. So take only 5 columns and with all rows or only particular 50 rows or 100 rows, you can take the help of LOC. And ILOC is index location. So range of location only possible. So range of rows and range of columns. You can't customize your columns. Okay. So second column I want, seventh one I want, 28th one I want. So you can't customize like that. Okay. You can customize only 0 to 5 and 10 to 6. Okay. Or 6 to 20, 6 to 15, 5 to 10 kind of thing only it is possible. The range only you can give. But you can't, it is not possible to give individual column names or individual locations, right? Using LOC, you can reorder your data. Second one, you can access, 10th one, you can access again, fourth one, second one, 8th one, 20th one. So everything is possible with LOC, right? In LOC, it includes the fifth one also. When you're slicing your data, so 1, 2, 5 you will get. 1, 2, 3, 4, 5 also you will get. Coming to LOC, 1, 2, 3, 4 only you can see. Okay. And regular slicing, 1, 2, 3, 4 only you can get. Fine. So this is the difference between regular slicing and LOC and ILOC. Okay. 3 types of slicing methods we have. See here, the output. So regular slicing, I'm getting 1 to 4. 1 to 4 I'm getting. And LOC 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And ILOC again 1, 2, 3, 4. Okay. Next. DF of LOC 1 column 5. So 5 columns 5 rows I'm taking with 2 columns. Okay. You can slice your columns here. Fine. You can reorder your data. So both things are possible here. Fine. Yeah. See here. LOC. Coming to brands. So coming to columns. So you need to give only one list of data. Okay. One list of data only possible. So how many columns you want to give? You can give inside the list only. Okay. Don't give directly brand, comma, current price, comma, something, column 1, column 2, column 3, column 4, column 5. Right. So you keep this all columns inside a list. Okay. So this entire list act like one object. Okay. One element. Fine. Hey, దాన్ని ఎందుకు డిస్టర్బ్ చేస్తున్నాను? Yeah. Here you have chairs. Fine. Yeah. So LOC is there to rearrange your data. Right. This is very, very important. LOC. Fine. You can customize your columns and you can create your subdata frames. Fine. So this is possible. Yeah. See here, coming to ILOC, 1 to 5, it means 1 to 4 records you can see, and 1 column 3 means one first column and second column you can see, right? So that is brand and current price I'm getting. Fine. LOC and ILOC. Yeah. Huh? It means no. No, it is not possible. Right? So that's what I'm saying. Here you can reorder your data. Okay. Which order you want, you can reorder your data. Okay. Everything is possible with LOC. So first current price, second brand, first brand, second current price. So you can do your thing. Fine. So both things are possible. Coming to ILOC, so it is not possible. It is following index rule. Fine. The range of index only you can pass. Same the range of output only you can get. Fine. So that is LOC and ILOC. Next we have so single value. So this is complete data you are accessing. So only from brand, from first row, only firebolt I want. A particular value I want to check. I want to see the particular value. Okay. You can take help of these 3 things. So DF dot LOC of second row from brand. Okay. Second row from brand. So that is both. Okay. And DF dot ILOC second row, first column. Okay. Same bot. And DF dot at second row in my brand. Okay. Same output you got. These 3 things are possible. So if you want to access a particular value, okay, you know the column name. Suppose you know the employee ID and you know a particular ID column name. Okay. Experience you want. So employee ID and experience you want to see, right? So give employee ID here and experience here column. So you can get, so maybe it's a 2.5. So you'll get 2.5 your output, right? So that is the way you can access your data. Like in Excel, we have index. Okay. In Excel, we have index, right? So equals to index, pass fourth row, second column. Okay. Fourth row, second column output I want. So you can see that cell value. So same here also, some this row and this column output I want. So you can see here df.loc of this row and this column and this row and this column, and you can see that one, right? You can use at, you can use LOC, you can use ILOC. So these things are possible here. You understood? So like lookups, I know the employee ID and I know a particular column name. So I want to know the lookup value, right? So you can use here. Rohit, आपका आवाज ज्यादा मिल रहा है. Fine. So this is extracting a individual value, right? Replace we have. Yeah, replace. Yes, replace. Okay. Yeah. So df dot head, we know that. Okay. Indexing particular value, we'll see. So here I have already in my data, I have indexing. Okay. Client providing data. So in the data, I have already index, but Python will give the default index. Okay. You can see here 0, 1, 2, 3, 4 and serial number also 0, 1, 2, 3, 4. Okay. So here, so in Power BI, we have used first row as my header. Did you remember? Suppose when you're this is clearly visible, right? Light. Brightness in that we need to change. Fine. We need to change here. Right side, you have a scroller. No, don't go. Right side, you have a scroller. Check. Beside the light. Scroller. Okay. Slowly scroll it. Slow, very slow. Slow. Scroll up. Scroll up. Scroll down. Yeah. Check the clarity. Very slow. Very slow. Check the clarity. Slow. Slow. Yeah. No. Come back. Earlier you got right. Right. Very good. Okay. And fine. Now it's clear. Letting that's it. In that a lot of settings is there. Okay. But you can see, right? Here you can come. Here you have a lot of space. Yeah. See here. Here. కనిపిస్తుందా మీకు? మీ చైర్స్ కొంచెం ఇంకా డౌన్ చేసుకోండి. మీద వస్తుంది చైర్స్ డౌన్ చేసుకోండి. లాస్ట్ డైరెక్ట్ రాగానే ఫస్ట్ వెనకకి వెళ్ళిపోతారు. आप लोग एकदम पहले आया, लास्ट चेयर पकड़ लिया. అతను అతను వెనక కనిపించదు. మరి ఇక్కడ కూర్చోవాలి, ఈ ప్లేస్ లో కూర్చోవాలి. ఇక్కడ 2 చైర్స్ ఉన్నాయి, ఇక్కడ కావాలంటే తీసుకో. ఫైన్. యా, అందరికి కనిపిస్తుందా? ఎస్. సో ఇండెక్సింగ్. So mostly you will get, you can face this situation in real time. So client will give that serial number, okay, index number in their data set, and Python will give the default serial number. So I don't want 2 serial numbers. Okay, you can go with 1. In Power BI already, so who completed Power BI, they knows. So we have first rows as header, right? Suppose they are giving data like from here they are starting, suppose any data something. So here they are starting. So here my first row is empty. So when you're loading this data into Power BI, okay, this empty cells only will give that column 1, column 2, column 3 as your column names, you can see. But real column names is first row, right? You can click the option first row as header. So everything will shift into as column names, right? So same here also you have rows, okay, row index values. Suppose you got like this, you can see, you can remove those things. So how can we remove? See here, my data frame dot set index. Okay, set index, serial number I want to set my index. Okay, you can set serial number, or you can set brand as your index. You can set current price or anything. Okay, any column you can set as your index. Sometimes maybe brand is index. Suppose you have unique names, all brands, so you can index your brand names. Okay, sometimes maybe you have product names, so you want to index as product name, so you can give that product name. So df dot your variable dot set underscore index, okay, of which column you want to set as index. Fine, you can give that column name, so automatically it will set as index. See, right now I don't have 2 index values, I have only 1 index value, that is my serial number, right? So this is setting index. Fine, so this is very important feature. So yeah, duplicate values, index values, so there is no sense. No, it creates. Yeah, so here it is not primary, it is not foreign keys, right? So you can create anything as index, but index are duplicates then. Okay, index are duplicates, but there is no use while creating in duplicate index values, right? So why? Because we are indexing using that. So if that is duplicated, no use. So you can drop the duplicates. Fine. Otherwise, you can create a new one. Okay. So like this, anything. Okay. Any feature, if you have unique values, you can go with set index. Fine. Yeah. Next, we have, see, you can see the data. So I have index set. So I got serial number as my index value, and brand, current price, and remaining are my data. So I'm checking df dot I always have 1 column 3 and 1 column 3. I'm checking. So first 3 rows and first 3 columns, right? 1, 2 and 1, 2. I got clearly. Okay. Next. So earlier data you want, suppose. Okay. Client's data. For that, you can use reset underscore index. So set underscore index means you are setting a particular column as index. Okay. And you want to come back, revert back you want. So df dot your, okay, df dot your variable dot reset underscore index. Okay. I'm resetting my index value again, right? So drop is equals to true. So again, same thing earlier I got. See, earlier I got 0, 0, 1, 0, 1, 1, 1, 2, 2. So same thing after resetting index 0, 0, 1, 1, 2, 2. Right? So again, it will revert back. Fine. So this is reset index. So just if you want to do that, you can do. Otherwise, you can go with only set index. Fine. Yeah. Next. Adding columns. Okay. So adding new columns. in Excel, simply right click and click on insert. You can create your new column, right? Suppose you want to create with year, so is equals to year, extract year from your date, so you will get the year. You want to find the profit, so actual price, so selling price minus actual price, so you will get the profit, right? So different ways you can create a new column in Excel. In Power BI also you can create new column, right? So click on this new column. You will go with DAX query, DAX formula, so you can create new column. In SQL also you can create new column, right? So everything is possible in all modules, right? So here also you can create new column, no issues. Suppose you have 8 columns, you want to find the profit. Okay, you have sales data, you want to find the profit. So here I have current price, original price, discount, some different features I have. I want to find the profit. Okay, or I want to find different sales percentage. Okay, some column I want to create with some formula, right? You can create your own formula here. Okay, you can create your own new column here, right? See here, that new column. Okay, this feature, my variable. Okay, my variable of this feature, which feature name you want to give. Okay, any feature name, profit or sales analysis, sales percentage. Okay, discount percentage or anything you can give as your new name, and give your column name, and equals to the data frame, same data frame, which column you want to minus. Okay, suppose selling price minus actual price, you will get the profit. Okay, percentage, profit percentage you want, so some percent profit minus something into divided by 100. Okay, you can do that one. So any new column you can create. Suppose here I'm doing current price minus rating, like this, any column. Okay, I'm taking this price minus some rating I'm minusing. So df dot head I'm doing. See, I got my new column. Earlier it is 990 minus 4, it is 986, right? So any performance, okay, plus you can do minus, divide. Okay, so everything you can do, you will get that output. So based on your arithmetic operation, you will get that output. Fine. So this is the way you can create a new column. Okay, so like this you can create. Suppose, so this is if you have data set. Okay, and one more method we have. Suppose it will create automatically in the last, when you're adding data, new column, so it will create automatically last. I want to create this new column in second place. Okay, after brand I want to see this one, so after rating I want to see this one. So anyway I got new data frame, you can reindex using LOC. Okay, you can reindex using LOC. So second place I want new, so LOC of brand comma new comma current price comma original price. Okay, you can give entire column names, you can get that output. That is possible, right? That is one way to reorder your data, reorder your table. And next we have one more way. Suppose I have a data frame. Okay, ABCD, some data frame I'm creating, so with some data, so index values I'm passing my own index values, so I got my output here. Yeah, see here, some data I have with 4 rows and 4 columns. Okay, 4 by 4. I want to add a new column. Okay, you can add likely df1 of e equals to some value you can give. Okay, dictionary you can give, otherwise you can give this one minus that one, or anything you can give. So here I'm using insert method. Okay, insert method we know in list, right? In list, if you want to add data in second position, fourth position, 10th position, you want to add data, you can go with insert, right? Insert method we have only in list. Okay, we don't have in another sequences, right? Insert is only possible in list. So here we have insert method. You can insert your data a particular position value, right? See here, at first position value, I want to insert. Okay, X is my column name. Okay, so insert syntax is first position, okay, next column name, and next data. Okay, next data. So you want to pass the duplicates, so simply you can give allow duplicates is equal to true. You don't want to pass the duplicates, you want to pass only unique values, so allow duplicates is equal to false. Fine, you can use like that. Otherwise simply you can go with normal. Okay, so this is just parameters only. So here index value, next column name, next values. Okay, data, your column data, right? Here I'm giving some X, some data. So name same like first one I'm giving. So it is X1, Y1, Z1. Suppose some data I'm giving. See, A, X, B, C, D. You can give same as capital. Okay, one more new column added. So earlier we have small x and now it is capital X. Fine. So like this, you can add your data into a particular position. Okay, you can add your column like this way. Okay, you can add your column like this way. Both ways you can add your column. And if you added new column using this way, you can re-add your data using LOC method. Okay, yeah. So here directly you are inserting a particular position value. Okay, so these two methods you have to add new columns. Okay, so this is possible. Fine. So next. So this is adding new columns. Okay, so adding new rows. How can you add?
Yeah.
Right now we don't have append method. It is removed from Python. Okay, from Pandas it is removed. Append method has removed from series and data frames. Okay, we don't have append. So for that we have concatenating. Okay, concatenation method we have. You can concat your two data sets. Okay, adding two rows means suppose you have data sets with 450 rows. You want to add more 5 rows. Okay, so for that 5 rows you can create data frame. So two data frames you have 450 rows with one data frame and 5 rows with another data frame. You can add these two, right? You can add these two in Power BI. We also in Power BI also we have append queries, right? There we have append queries. In Excel also we have append queries. Okay, and in SQL we have joins, right? So these are all things possible. You can append your data. Sorry, you can concat your data. Fine. Yeah. So how can you do that? DF2, some index values I have. So DF2 dataset I have. I want to add DF1, DF2. Two datasets I want to add. Row level I want to add, right? So for that you can use pd.concat. See here. Row level it is added. Okay. Row level it is added. Fine. You understood? Creating column using insert and using regular method. And here creating new columns. Okay. New rows, adding new rows. Fine. So like this way you can add your new rows. So this is row level. Okay. Access is equals to 0. Default concat is access is equals to 0. You want to add this data at column level. Okay. You want to add new rows at column level. Fine. So for that thing, you can use DF4 I'm using. So always take new variables, concat, comma. That's it. Okay. So like this way, you can add your data. Got it? Right? So here I don't have data, so that's why it is showing as none, none, none. Fine. It is null values. So here I have data, so it is no null values. So it is column level, it is adding. You understood everyone? Right? Yeah.
Rajesh, can you repeat this again?
Yeah. So earlier already we discussed adding new columns. Okay. You can add your new columns using this way and this way. Insert method we have. Right? Using these two ways, you can add your data. And how can you add rows? Okay. There is a probability of adding rows. Right? So how can you add new rows? Fine. So for that, you have a data set. Okay. I have a data set. Suppose this is 2000 rows and 10 columns, suppose I think. So assume like that. I have data like this. So So this is my data frame 1. Next. So I concatenate. Next, I'm concatenating here. So df3 is equals to pd.concat df1 comma df2. Okay. Always concat accept only one element. Okay. Concat accept only one element. So I am creating these two data frames using a list. Entire list is act like one element, right? Entire list act like one element. Suppose you have data frame 3 also, give comma data frame 3, 5, 6. So comma 5, 6, 7, 8, 9, right? So all data frames combined together, we created a list, and this entire list act like one element, right? So I'm giving concat of that one element. I'm passing two values here. So it is adding, right? So here already I inserted some data x1, x1 and y1, y1, z1, right? So two new columns I inserted, right? So this is my data frame 1. So here it is data frame 1. And next I have data frame 2. There is no x column. I have only ABCD column. So where it is matching? ABCD. See, A is matching, B is matching, C is matching, and D is matching. And X is not matching, right? So at the moment, these two are my null values. Remaining all are my matching data. Okay. So be careful when you're appending data at row level. So must and should column match. Okay. Your column count must and should match. Otherwise, it will create automatically null values. Okay. So this is important one. Suppose you have sales data, today sales data, and yesterday sales data, day before yesterday sales data you have. So sales data definitely having same column. Just we are adding new data. Every day data only we are adding. So remaining column, remaining feature names are obviously same, right? You want to add this 3 days of data. You want to add this all data, every data you want to add your old data, right? So for that thing, you can use append method, right? So anyway, my feature names are same. Just I'm adding new data, today's data, yesterday data, and maybe tomorrow's data. So I'm appending my data, right? At last position. Okay. So for that scenario, you can use concat. Why? Because all my rows, all my column names are same. Okay. Next, this is one way to add data. So by default, it is access 0. Okay. Default access is 0. I'm passing access 1. Column level, I want to add my data. Okay. Column level, I want to add my data. See here, concat df1 comma df2 access is equals to 1. Right? So I have 4 columns in my first data frame. I have 4 columns in my second. Sorry, I have 4 rows in my first data set. I have same 4 rows in my second set data set. So that's why there is no null values. Right? My rows are matching. Columns, anything it may be. Okay, my rows are matching. So no null values. Suppose you have only 3 rows in my data frame 2. So this entire thing is my null values. Right? You understood, everyone? Yes. Is it fine, Navin?
Yeah, it's okay. Right.
Yeah, fine. Very good. So this is the way you can add columns and add rows. Okay. Next. So you can analyze your data with one variable, with 2 variables, with multi variables, right? Multi means 3 or more variables. So that is very common. So for that, I don't need to go deep, right? So pld.hist. Okay. I'm using hist plot for single variable analysis, univariate analysis, right? Yeah. DF of brand. I want to know the brand frequency. Okay. Yeah. I have only few brands. That's why I'm taking brand only. So model, some different differences there, but model I have 3 IT unique values. So it is not fixed in one chart, right? So that's why I'm taking this brand one. So brand is 18 only. So see here, pl.hist. Okay. So always it will accept only the plot name. Okay. There is no plot kind of thing. If that is Cborn, hist plot, disk plot, strip plot. Okay. You can see the end plot kind of thing, right? So here you can see only hist, bar. Okay. Line. So line means plot. Okay. And box. So those kind of things only you can see here. You can't see the entire plot kind of thing, right? So here it is plt.hist I'm using. Hist is useful for single. Okay. Univariate. Yeah. Frequency distribution. Okay. You want to see the frequency of data. How much frequency is there? Each unique value. What is the frequency? Okay. Suppose you have Apple brand. How many counts is there? Frequency of that Apple. Male, female is there. What is the male frequency and female frequency? Regions is there. What is the south frequency, north, east, west frequency? How many people are living in south? I want to know the frequency. Values count, right? So for that scenario, you can use histogram, frequency distribution, right? Yeah. See here. So everyone, I hope this thing you know, right? Everyone knows about this figure size. Okay, this is very important one. So default figure size, if I'm not passing this one. Oh no. See, you can see this is default. Okay, default figure size, right? So like this, you can see. Fine. If you remove this one and if you add figure size, you can see this one. Okay, size I'm declaring. My image, my figure size I'm declaring. So for that one, syntax is plt matplotlib dot figure, okay, of figure size, okay, fig size equals to width into height. Okay, first it accept width and next it accept height. Okay, width comma height. Fine. So width I'm giving 12 and height I'm giving 5. So I got 12 by 5. Okay, width and height. Fine.
Before defining the type of chart, we have to define the size of that chart.
Yeah.
Or is it possible to first define chart then the size?
So you are asking if what happens if you define last. It is interpreter, right? Line by line execution. So first it is executing this line, and next it is. So there is no figure to do this one. Suppose after this, if you are printing another chart, so next chart follows this one, right? So like this. So PLC dot X label, we know that. Okay, PL dot Y label dot X label, some name, brand. Okay. Y label is count. Okay, count brand. I got fine. X label you can give, Y label you can give, and next we have X ticks. Okay, so without this, see overlapping. You have big names. Okay, you have big names. So this is 180 degrees. Okay, it is 0 or 180 plane. Okay, 0 or 180 plane. So it is overlapping. So I want to see these clear names. Okay, for that you can use plt dot x ticks. Okay, x ticks, my X label is rotation is 45 degrees. 45 degrees rotation. Okay, you can give any degrees. Okay, 90 means straight one you will get. Okay, 60 degrees, 30 degrees, 20 degrees, that is completely your choice. Okay, X ticks. Now it is, you can read easily all column names. Okay, so anyway I have 18 brands. Okay, anyway I have 18 brands, but it is giving 3 and 6 and 9 10. Default it is giving 10 bins. Okay, default histogram is giving 10 bins. Okay, so here this column width you can adjust. So R width is equals to 0.5, 0.8. Okay, suppose it is 0.8, you will get the big columns. Okay, so that is manual things, you can do anything. Yeah, so it is giving only 10 bins. Your entire data is fixing in 10 bins, right? So here bins is not possible. Okay, so for that we are using Seaborn. Okay, same data, same graph. Okay, see here, same figure I'm using, figure size 12 by 5 and sns.histplot. Okay, Seaborn.histplot. df of brand I'm using, same brand. KD is equals to true I'm passing. So then I will get this line and color is equals to purple. So any color you can pass based on your criteria, red, blue, green, black, anything you can pass. So I'm passing purple. So next pl.xtix is equals to 45 degrees I'm giving. Sure, I'm doing. See, so it is giving for each brand, it is giving different bins. Okay, you can adjust your bins. Bins is equals to 5, bins is equals to 8. So those things are possible. You can pass your number of bins here. Fine. So based on the data, it gives the distribution. So you can see this KD line, the distribution of your data. Okay, so this is normal way. Next, So finding outliers. Okay. So this everything comes under manipulation. Okay. Univariate. I'm taking only one variable. Fine. I'm doing the box plot. So SNS dot box plot DF of current price. So is there any box plot? You can do with all columns. Okay. For discount percentage, you can do outliers. Okay. For current price, you can do for any numerical data, you can find the outlier. Okay. Just I'm taking this one.
For every column separately, we have to solve.
Yeah. Okay. So like this, you can do your outliers. You can find the outliers. See, I have outliers. Okay. Lot of outliers I have. Fine. So this is just finding the outliers. So before manipulating the data, I am checking if there is any outliers and if there is any left skew, right skew, different type of data I'm checking. Okay. You can do that way. So value counts you can find. Okay. Value counts means like it gives the count, how many unique values is there and what is the count for that unique values. Fine. See, brand I have these many unique brands and how much count. See, frequency firebolt is high. So that is 60, 43, 41, 33. So you will get like this. So hammer is only one. Okay. So it gives the value counts. Value counts is very useful in real time. So what is the frequency of each and every value, each and every unique value? Fine. So it gives that unique value frequency. Value counts it will gives. Okay. For two variables also you can give value counts, comma, some model. Okay. Model also you can give. Everything is possible here. Fine. Group by. Okay. Group by also you can do see df dot group by brand. I want to group the data. Okay. And always group by accept a arithmetic operation anywhere in SQL also. Right. Anywhere group by accept a arithmetic operation. Right. So you are grouping your data and remaining values in which format you want. Okay. Remaining values I want in the count format. I want in the sum format. I want in the mean. Okay. Average I want remaining values. So then you can go with it is count I'm doing, right? Yeah, it is giving count. Suppose you want the sum. Count means it gives text data count and numerical data count. Suppose if you are using sum, it gives only the numerical data output. So remember this one. See. Okay. So image fit. Okay. And see, serial number count is 3, 4, this one. And current price sum is so and discount percentage rating sum and number of rating sum and new sum. Fine. So it gives the sum. And you can't see this text type of data. Okay. Models you can't see and original price you can't see here. Why? Because I'm doing sum. Sum is not possible for text data, object type of data, right? So this is the one. Mean also you can perform. What is the average price for each everything? Right? See. So see, Apple average price is 43,161. Okay. And see, Firebolt average is 3,280 and Fossil 15,232. And next Huawei 15,000, Noise 4,000, Samsung 25,000. So like this, you can check everything. Okay. So average rating also you can see 4, 4, 4, 3. Okay. Both 3.9 and see 4.5 Apple is the maximum one, 4.5, 4.4 Fitbit, 4.4 Garmin, 4.2 Samsung. Okay. 4.3 Huawei. And number of ratings, who got highest ratings? Okay. 47,000 both. 37,000 noise. That's it. So these are high. Okay. Yeah. Like this. This is your analysis. You can find the group by, you can analyze your data, right? After this, create a new column and so make it as a comment and who got highest ratings. Okay. 4.55. Okay. Apple got high ratings with 4.55. Okay. And number of ratings. Okay. It is 37,000. Next, it is 47,000. Both with 47.5K. Right? So read the data. Okay, read the statistics, what it is giving, analyze those things, and write your analysis. Okay, for every column. Okay, you add a new row, you add a new column, and what is your analysis? After adding, is there any null values? Okay, after adding, I got 5 null values. After adding, I got 10 null values. Okay, after adding new column, I got this one. After adding new column, I got this one. So write as your analysis. Okay, after value counts. So this is the high frequency. Firebolt is the high frequency. Many times it is repeated. Okay, so high frequency brand is Firebolt. Low frequency brand is Hammer. Okay, so you can find that one, and group by value counts and frequency of distribution. So what is high frequency in your data? Okay, what is high bin? So in 10 to 20 range, there is high bins is there, high frequency of bins is there. Okay, and 40 to 50, there is high frequency of bins is there. So what is your analysis? Right? So after outliers, so this much of outliers I got. Okay, so in my current price I have outliers, in my brand I have outliers, so in my ratings I have outliers, in my discount price percentage I have outliers. Okay, so like this, what is your analysis for after every column? Okay, after every code you can write your analysis. What is your observation? What is your decision? Okay, what is your analysis? What is your insights? So you can write anything about that column and about that row. Fine. So this thing is possible. Next, cutting bins. We know that, right? I have discount percentage in the range of 0 to 70 or 0 to 90. Okay, 91 is highest maximum discount percentage. So some discount is I have. So I want to create only 10 pins. So which discount percentage those are all comes under? Suppose first row is df dot head. Yeah, see here discount percentage where it is. Yeah, 7.6 I have first. Okay, so I want to rate it as it is comes under 0 to 10. Okay, it is comes under 60 to 70. Sorry, 70 to 80. It is comes under 70 to 80 again. 90 to 100, 60 to 70. Okay, like that I want to define. I don't want these many type of unique ones. Okay, I want a particular one. Only 10 bins I want. Okay, so 0 to 100. So 0 to 10 is 1 bin, and 10 to 20, 1 bin, 20 to 30, 30 to 40, or 90 to 100. Okay, like this, I want to create only 10 bins. I don't want, I have, suppose, in this, I have maybe 140 or 180 unique values in my discount percentage, right? So I don't want these many unique values. I want only few, on 10 bins I want to create. For that scenario, you can cut the data. Okay, you can cut the data into different bins. Fine. So this is possible here. So for that, you can use PD, your library, pandas dot cut. Yesterday, someone asked one question. So is PD and pandas same? Okay. In yesterday's assessment, we gave pandas dot some data frame, pandas does data frame, some data we give, right? So at that moment, so they are thinking pandas means it is wrong syntax. Okay. PD only right syntax they are thinking. Okay. So PD or pandas, both are same. Okay. You can use pandas, you can use PD. Just we are every time writing pandas. So it is very lengthy one, right? So that's why just we are assigning alias name.
So like if we have already defined alias, still we can.
Yeah, you can use pandas. You can use pandas, no issues. Okay, why? Because we are importing pandas. Okay, it is imported. You can use pandas as well as PD. You can use cbon. Okay, you can use random as RD. Okay, random as RD you can use, or simply random also you can use. Okay, you can use directly pandas or PD you can use. Okay, so PD and pandas both are same. Okay, you can give your alias name any name. Okay, it is not fixed for PD, but universal shortcode is PD. If anyone seeing your code, if they are observing with PD, so they can understand easily this is pandas. Okay, anyone seeing your code that is SNS, anyone can understand that is cbon. Okay, so don't give your own personal choices. Okay, always go with universal codes, that is SNS, PD, RD, PLT, right? So those kind of things is beautiful always. Fine. So I'm taking PD dot cut my data into number of bins. I'm giving my column that is discount percentage, and I am declaring I want 10 bins. Okay, earlier I have number of bins. Okay, earlier I have different unique values. So those many bins it will create. But I'm declaring here, I want 10 bins only, right? So my column, comma, 10 bins, right? So it will cuts your data into 10 bins automatically based on your data. Okay, automatically based on your data, it will cut into 10 bins. See here in the downside, you can see. So minus 79.8592, 62.619. It is one bin. Okay. If your value is suppose minus 72.4, it will comes under first bin. Okay. It will comes under first bin. Suppose your value is 26.7. So it will comes under this bin. Right. So this range 22.7272 to 39.797. In this range, if you have value, so that value will comes under this range. Everyone understood? So this bin, this is creating bins. Automatically, based on your data, it will cuts into number of bins. Okay. So anyway, I don't want like this 5.66. These many decimal values I don't want. Okay. So this is not looking good. Fine. So I'm giving that bin labels also I'm giving 0 to 10, 10 to 20, 20 to 30. I am giving some data, right? So for that scenario, you can use, see, X is equals to data I'm passing. Bins is equals to 0, 10, 20, 30, 40, 50, 60, 80. Or 90, 100, minus 10, minus 20, minus 30, minus 80. You can give your number of bins. Okay. I'm taking from 0. Simply. Okay. I don't want minus things. I'm taking from 0. Fine. So see here. So first value is earlier we seen 7.5, 7.4 something. My first row value. Did you remember? Here we have, see, 7.6. So where it will fall? Under 0 to 10, right? See here. 0 to, it is falling under 0 to 10, right? So it is also looking not good. 0, 0, comma 10, 0, right? So for that, you can give the label names also, right? It is only bins. It is default bins, right? My value is 7.5. So it is under 5.6 to 22.7, right? 7 is 5.6 to 22.7 in between, right? Yeah. So it is giving default one. Here I'm declaring 0, 1, 2, 3, 4. So 0 to 10 it is giving. So, but I don't want 0 to 2 bins. I want to give my own bins, right? So labels is equals to 0 to 10, 10 to 20, 20 to 30, and like this kind of. Fine. See, it is 7, right? So it is coming under 0 to 10. Like this, you can create your number of bins. Okay, right. See, that bins, I'm giving the value counts. Okay, see, 60 to 70, I have 90, 70 to 80, I have 57. So like this, different things I have. 0 to 10, I have 31. Okay, like this, you can get the value counts, right? So value count means the count, okay, frequency of count. How many counts, how many values is there? Okay, yeah. His plot for that, see, discount percentage and color is equal to hot pink I'm using, KD is equals to true. So which type of data this is? Anyone? Which type of data this is? Negative? Skewed? No. Why? How it is negative skewed? Your complete data is positive way.
It depends on the tail, not of pink and
Huh?
the tail.
Yeah, negative tail you have, left tail you have, and it is right skew. Yeah, so that is skew. So this is completely right skew and left tail you have, right? So if you want normal distribution, you can remove these minus values. Okay, don't consider the minus values. You can take the only positive values. Then it is normal distribution. See, you can see this one. Almost it is normal distribution. Only the left tail is damaging my data. Right? So this is your frequency of distribution. This is the use of KDE first of all. Okay, use of KDE. So in stats, maybe sir taught you, right? So always this one, right? Or kurtosis. So these are all your distributions, right? So how can you get distribution? Using KDE, right? Using KDE only, you can see that distribution plot. Okay, how my data is distributed. For each and every column, first of all, you need to do this KDE plot. Okay, then you can understand which type of data we are getting. Okay, so is that left skew data? Is that right skew data? Is that normal near to normal distribution? Is that kurtosis data? Is that lipo mixture kurto? Right? So which type of kurtosis you have? So those kind of thing it will give, right? First of all, after loading the data, so before manipulation, you need to perform these are all things, right? Box plot and KD plot and histogram, right? So these are all things first of all you need to do before cleaning the data. And after cleaning the data, I can perform this one. Okay, then still it is you have outliers, still you have left skew data, still you have right skew data. After applying some methods also, then you can take some decision. Okay, so that is possible, right? So like this way you can find your frequency of distribution, right? So this is only single variable analysis, one feature analysis. You can, yeah, here I'm doing only for discount percentage. You can do for all. Okay, you can do for all. Bivariate means two variables, right? So line plot, bar plot, strip plot, scatter plot. Okay, any plot you can do which plots are accepting two features, two variables, right? You can go with those many plots. Okay, you can analyze your data. See, figure size I'm declaring. Line plot x is equal to some data, y is equal to some data. Data I'm passing. So I got this line plot. Okay, like this. Correlation. Variable 1 dot correlation, variable 2. You can do like that. See, I got 0.39 correlation. Fine. So this is multivariate. Sorry, bivariate. For multivariate, correlation for entire data. So it gives some warning. Why? Because in that you have text data and in that you have numerical data. So for all things you are finding correlation. So that's why it is giving some error. Okay. Valid columns or specific columns values numericals only. So that's why you are getting error. Correlation. And this is correlation for entire data. Okay, complete data. And this is correlation for only numerical values. Okay, numerical values you are getting. See, df dot correlation. This is my parameter. Numerical underscore only is equals to true. Okay, only numerical data you can see. So without this, you will get the error. Okay, see, finding correlation of the entire data set. That's why it is giving error. So I am giving numericals only. So you can't see that error. Okay, yeah. See here, I am using heat map. Okay, heat map is good for correlation. Okay, you can use pair plot even. Okay, I'm using heat map. So df2, I'm passing correlation data here and C map. Okay, C map means this is my C map. Okay, this is my C map. Okay, colored map. Fine. So what is your color? See here, I have black color. It means you can see dark black means it is minus 0.6. Okay, based on this C map, okay, color map, you can create your image. Okay, so if I'm not passing annotations, see, now how can you understand what is 0.6, what is 0.8, what is 0.5, what is 0.2, what is 1, 2, 3, right? Not 1, 2, 3. So in middle minus 0.12, in middle minus 1, 2 plus 1. Okay, how can you understand? So you can't understand this one, right? So that's why we have C map. Okay, see here. So which color is black? Okay, where you can see the black one, that is minus 0.6. Okay, that is minus 0.6. And which one you are seeing with light, this cream color or some color, that is plus 1. Okay, which colors you are seeing with this color, gold color or some light peach color, that is plus 0.06, right? So where you have see this is 0.4, maybe this is 0.4, right? This is some light purple and this is maybe 0.2 to 0.3 in between. So this is 0.0 something. So this is 1, this is 0.6 minus 0.6, right? So you can do like that. So I'm giving annotations. Then you can see it is 0.2. Right? So that is C map, color map. Fine. So I'm giving magma. Okay. You can give grids. another color. It is a combination of purple to yellow. Okay. Or you can give Mako, anything. Okay. These are all possible. You have hundreds of data, right? It is the combination of black and blue, ocean blue, right? So
So
every,
FMT is equal to 0.1 F.
yeah, this one. Okay. Points. Okay. Digits after decimal. Okay. How many points you have? I want 2 points. Okay. 2F. Yeah. 0.09, 0.63, 0.3 points. Okay. 0.92, 628. That is your choice. Fine. So I'm going with 0.2. 0.2 also nice one. 22, 20, right? Kind of thing you can see. Or any beautiful color, which one is looking good, you can go with that one. Rocket are also nice. This light peach color to black. Fine. So that is your choice. Which color you may like, which one is looking good, you can go with that color. Fine. Yeah. And figure size also you can define. 10 by 6 I'm using. Okay. That is your choice. So based on the data, it gives the size. Fine. So that is heat map correlation. Strip plot. This is also, I'm using cube. So it is also multivariate. So more than 3 or more than 3. So figure size I'm declaring 12 by 4, and strip plot or scatter plot or S1 plot, anything you can use. X is equals to X data, Y data I'm passing. Data is equals to I'm passing. Use brand. Okay, I have only brand, only have unique values, very less unique values. So that's why I'm taking brand. I'm running my data. So yeah, legend I got, and this is my data. Okay, like this you will get. Next, dealing missing data. Okay, handling. So up to here it is my analysis only. Okay, adding new columns, adding new rows. Okay, and visualizing the data, univariate data, bivariate data, multivariate data. Okay, this is your analysis. And what is your observation? You can write in the downside of your chart and downside of your code. Okay, wherever you want. Next, handling missing data. Fine. So anyway, definitely we'll get missing data, null values, blank values in my data, right? How you are handling the data, that is very important. Okay, how you are handling. So how can you find null values? Is null dot sum, right? You will get the null value sum, right? So two methods we have to handle the data. One is dropping, another one is filling. Okay, you can fill your data and you can drop your data. Otherwise, keep it as same. Okay, you can go with null values. Fine. So there's 3 ways. So you can go with the same way, means that is we can consider. So 2 ways we have to fill the, so deal the null values. Either fill the value or remove the value. Right. So removing values is not possible in real time. Why? Because we don't want to lose the data. Right. So even single valuable customer also we don't want to use that one, lose that one, right? So removing is not possible in real time, but you can remove with the permission of your managers, team leaders, and your clients. Fine, you can do that one. Okay, yeah. So here I'm finding some blank values or null values, some data. Okay, so before doing this, first do the copy. Okay, as your first step is copy. Okay, after loading the data, as your first step is copy. Okay, and before cleaning the data, before removing the handling missing values, do one more copy. Why? Because here we are using in place is equals to true. Okay, so if you do any mistake with that one, so simply it does permanently. So that's why always go with copy. Okay, always go with copy. So that is safe. Fine. Yeah, I'm doing copy here. df 10 is equals to df dot copy. Okay, already df1 I used earlier. Yeah, df10 is equal to df dot copy. I'm doing, yeah. First one, fill now. Okay, I'm going with filling method. Okay, I'm going with filling method. So df of current price. See here, in my current price, I have 10 null values. Okay, I want to fill that null value with average price. Okay, or with mod frequency, high frequency, or with mean, with sum. Sum is not possible. Why? Because we will get huge sum. Okay, huge sum you will get. So mean is always best. Why? Because it is the average one. So based on the data only. Okay, which type of data you are filling based on the data, which method you are taking. Okay, that is very important. I am taking mean. Okay, that is price column. So I want to fill that price with average. Okay, see. So this entire thing you can assign into variable. Some variable is equal to df dot mean. You can assign to variable. That variable you can use here. Value is equal to that variable. Otherwise, you can directly use your mean value here. Fine. In place is equals to true. That's it. I'm checking is null dot sum. Only this current price. Okay. It is 0. Earlier we have 10. Now it is 0. Done. I used in place is equals to true. The operation is done permanently. Okay. Yeah. Next we have forward fill and backward fill. Okay. We have pad also. So that is removed from 2.0. So don't go with that one. So here we have B fill and F fill. Okay. Backward fill and forward fill. So here I'm using for model name, I'm going with forward fill, F fill. So fill na method is equals to F fill. Okay. In place is equals to true. I'm doing this. So 0. Earlier I have 15, 35. Okay. You understood? As well as you can use B fill. Okay. And remember one thing, if you are using B fill or if you are using F fill or if you're using mean, mod, median or sum or count, any method you can use to fill the values. Okay. But you need to give the explanation about your filling value. Why you are taking only this method? Why not another method? Okay. Why you are using only F fill method? Why not backfill? Why not value? Okay. So for that matter, you need to give the explanation to your boss or to your client or any fine. So that is important one. Okay. So based on your data, which method are suitable for the data, you can take the decision. Fine. So that is very, very important. In interviews also, they will ask question. Suppose I have data with some null values. So what you will that, okay, how can you handle the data? Okay, if you do you want to remove the data or do you want to fill the data? So which methods you apply? Fine. So is there any scenario you face like this? Okay, is there suppose null values you have? So how you fill the data? Okay, so in real time, so have you faced any situation, any scenario? So you need to explain that. So for that matter, you need to prepare more data sets. Okay, then you can understand for numerical data, which one is suitable, for text data, which one is suitable. Okay. For text data, mean is not possible. Right? Count also not possible. Count gives count. How will you get count? Count means it gives 20, 30, 40, 50 count. Right? So big fill, B fill, and F fill, it is good one. Frequency. Okay. So like that you can use. Fine. So this is my filling methods. Fine.
Sir, what exactly would be output of F fill and B fill, sir?
Uh,
Output of F fill, what would it be like?
what is
F fill and B fill.
forward fill and backward fill?
Yeah, how does it show up in data frame?
Oh, do you know this one? For don't know this one?
No, sir.
Which batch you are?
68.
68. Okay. Did you complete your Python?
Yes.
Still you don't know?
No, sorry.
Fine. No issues. Okay. Yeah. Suppose I have data A, B, C column. I have my data 1, 2, 3, none, and 6. Okay. I have data and 1, none, 2, none, 4 kind of the data I have. Okay. When I am using forward fill, F fill, it will fill data with forward value. Okay. And when I'm using B fill, it will fill your data with backward value. Okay. That's it. Simple. I have data at fourth line. I have null value. So when I'm using backfill, so it will fill the data with back value. Okay. And it will fill data with forward value. Okay, suppose in my top I have Apple. So here I have blank value. So it fills with Apple. Here I have Samsung. Here I have null value. So it fills with Samsung. Okay, that is forward fill and backward fill, not above and not below. Only one step back and one step forward, one step forward and one step backward. Okay, so this is only possible. And I don't want to use this forward and backward. I want to use, suppose I have different rating 4, 3, 2, and 6, 7, 1, 2, 3, 4, right? So I want to fill with average. So at that moment, there is no forward, there is no backward. Find the average of entire column and fill with that null value with average value. Okay, and count. Suppose you have count is 10. So I want to fill with count. So value is equals to give the count. So it will fill with 10. Okay, or directly value is equals to directly value is equal to 15. You can give no issues. Okay, if you know the value, you can give directly 15. Fine. So that is possible. You can give based on the data. If you know the value, so which value you want to fill? Suppose 10th student data is there. So you know 10th student's age. So averagely it is 15, 16, 17. So you can fill with values equals to 15. You no need to find the average. Right? Directly you can take the decision. I can fill with 15, I can fill with 16. Right? So that is filling that value is equal to 10, value is equal to some value. Okay. Suppose you have south, north, east, west data. Okay. You can directly take value is equal to south. You can fill your data that value is equal to north. So which frequency is high? You can take the decision. Value is equal to north, value is equal to east. Okay, value is equal to male, value is equal to married. So anything you can pass directly. Otherwise, you can take the help of mean, mod, median, and count, frequency, or everything. Fine. So that is possible.
So you are building a model, can you pass that data as it is with missing values?
When?
While you are building a model, missing a model,
Uh-huh.
we have data frame null values.
Uh-huh.
Can you try that data using the data frame? Can you try this model, or else we need to fill that missing values definitely?
That is not mandatory. Okay, when you have more missing values, then your model will it won't give the exact output. Okay, exact prediction. Okay, when you're filling your value, so you can try it like that. You fill your data with backfill, or you fill your data with forward fill, you fill your data with value. Okay, three methods you can use. You do first 3 copies. Okay, for each copy you apply different methods. Fine. After that, original data you have and 3 different methods data you have, right? For these 4 data sets, you apply training and testing 70-30 or 80-20 and do your analysis, give your prediction. So different values you will get, right? So in which scenario you are getting more accuracy? Okay, suppose forward fill is giving 82%, backward fill is giving 72%. Okay, null value is giving 50% only. Okay, and value method is giving 91%. So which one is giving more? Okay, which method is giving more? So all methods will work. Empty values also will work and filling values also work. But which method is suitable for your data? Okay, which method is giving more accuracy? Confusion matrix. Okay, which accuracy is more? Right? So true, false, and false, true, false, negative. So in that, which one is, where is false, negative values are more? Where is true, false, negative values are more? Okay. Where is true, positive, and true, negative values are more? So you can do your analysis with confusion matrix and your accuracy score, right? So CV score. So those are all things possible. Find which prediction are giving more, and after that, predict your value. You have given these 4 inputs, right? So you given training and testing for all four same 7-3, 7-3, 7-3, 7-3. Okay, and after that prediction, you are done with your prediction and cross this testing and training. Right, after that you got 72%, 92%, or 71, 75% you got, right? After that, predict your data. Why predict? Okay, some value you can pass. Some brand is equal to something, and suppose student data. Math marks is equal to 25, science marks is equal to 24, and English marks is equal to 20. So he's pass or fail. You want to perform that analysis. So in which model you are getting exact accuracy, right? In which model is giving more accuracy? So exact prediction, whether the student are pass or fail. In real time, we have some data, okay? And you can give the same data and here whether the student fail, okay? And here you are getting pass. So no use of prediction. Right? It is wrong. Here the student is fail and here you are getting same fail. So it is exact one. But in that, which model is giving more accuracy? Okay, so 92% I'm saying definitely if you pass data, 92% you will get the exact output. Okay, accuracy means that one only, right? So 50% you are giving. So there is a probability of getting failure, right? Right, 52% means definitely. So maybe if he is pass, maybe you will get fail there, and he is fail, maybe you will get pass. So that is 50% criteria. 70% you are giving accuracy. So 70% you pass your data. So it is 70% is correct. 80% is correct. 95% is correct. So that much of accuracy is required. Okay. For that, which model is giving more? So is decision forest, random forest giving more, or is decision tree is giving more, or linear regression is giving more? SVM, KNN. So in that we have two types: regression and classification. SVM classification giving more, or SVM regression giving more. First, you need to divide the data. Is that regression data? Is that classification data? Right. So after that, import your data sets, sorry, import your libraries, regression libraries and classification libraries. So that is very important, right? So like that, you can go with null values also, even no issues, but how much accuracy it is giving. Okay, so that is important. So machine learning, there is no complicated. That is very easy. All steps are already predefined. You no need to apply your logic. Okay, so how can you get frequency, right? How can you get accuracy score? So why predict, right? How can you predict the data? So give that syntax and pass your values. That's only we are changing the values. Syntax is for all models. Syntax is same, right? For random forest, we are using RFC. For decision tree, we are using DCC, right? So for linear regression, we are using LR. That's it. We are changing only that LR, DCC, and remaining thing. The remaining parameters are all common, right? So that's it. We are changing only the names and we are changing the data. That's it, right? So everything will give the same different output and same syntax, right? But why this one is giving more? Same like FFIL, BFIL. Why you are using this method? So in machine learning also, why RFC is giving more? Why DSCC is giving low? Why KNN is giving more? Why SVM is giving more? So this analysis is very important, right? Anyway, ChatGPT or AI will give this accuracy score and outputs, but it don't give that explanation. You need to explain about the data, why it is giving more. So there we have null values, there we have high frequency, there we have outliers. So that's why this method is giving more accuracy. So KNN is very good one. So when you have outliers or when you have blank values, you can go with KNN. So which one is near to that one? So it will fill with that data, right? To filling the data, you can use KNN even, right? K nearest neighbor. So which one is near to the data null value? It fills with the data. Automatically it will fills, right? So you can use machine learning KNN model to fill the null values. There in machine learning we'll see, right? So already you completed your machine learning part, right? Next, okay, which batch you are? 67. Okay, fine. So there we have methods. So how to fill the null values with KNN? Okay, how to impute the null values with the remaining methods, right? So KNN C we have, KNN R different regression and classification different methods here. So how you are filling the data at that point? Okay, you no need to use these all things at that place. Fine. So those things are high level. Fine, we'll see later. Yeah. So drop now, right? Dropping null values. So in place is equal to true. It drops your null values permanently. Okay. Drop now is only view. Okay. It is not permanent. Fine. It is only view purpose. It deletes the data only for just view purpose. Fine. If you want to delete the data permanently, use in place is equal to true. That's it. Fine. Yeah. Next, you have duplicates. Okay. Suppose if you have duplicates in your data set, okay, df dot drop underscore duplicates, it deletes the duplicates. Fine. Automatically, it will delete the duplicates. And you can find the shape even. See, I'm getting 450 by 8. So it means there is no duplicates. Okay. Boss. Okay. Df dot drop underscore duplicates. Okay. I'm dropping duplicates. Anyway, in my brand, I have duplicates. Okay. In my current price, I have duplicates. In my original price, in my discount rating, number of ratings. So always on all columns, I have duplicates. In model also, I have duplicates. 100 duplicates I have. But still, it is not removing duplicates. Why? Yeah. So here in serial number, I don't have duplicates. Okay. It is considering serial number as main one, right? So in serial number, I don't have duplicates. So it is considering that one. So if you have duplicates in your serial number, then it deletes entire row. Okay, then it deletes entire row. We'll see with practice. Yeah, here I'm creating a data frame, small data frame I'm creating. Brand, Apple, Samsung, okay, and style curved or curved and edged. Okay, two styles I'm defining, and ratings 4, 4, 3.5, 4.2, 4.5. Okay, I'm giving exact data. I'm declaring a data frame, right? I got a data frame, brand, style, and rating. So with some rows and some columns. Okay, so here I have some duplicated data. See, Apple curved 4.0, Apple curved and 4.0, right? Samsung curved 3.5, Samsung edge, and 4.2, 4.5, right? So here I have only these two rows are completely duplicated, right? These two rows are completely duplicated. When I'm using df dot drop duplicates, without ignore index is equals to true, I'm doing 0, 2, 3, 4. Okay, it is removed the second one. Okay, it is removed the second one. See, I got only Apple curved and Samsung curved, Samsung edge and Samsung edge. Okay, so it is deleted one duplicated row, that is this one. But I didn't get the proper index, right? For that scenario, you can use ignore index is equals to true. You will get the proper index. Now you see the 0, 1, 2, 3. Right? You understood? So this is use of ignore index is equals to true. Fine. And there we have in place is equals to true. Got it? Yeah. It is removed. Okay. Yeah. Suppose if you want to remove a particular one, df of one small one, right? Oh, what happened? Right? It is removed the duplicate brands. Okay, only Apple and Samsung I got. Right? Like this you can do. I'm going with entire data frame. Okay, like this you can drop your duplicates. Next we have concatenate. Okay, adding 2 data frames or 3 data frames. I have data frame 1 already we discussed in the top, concatenation. Okay, and next we have handling outliers. Okay, finding outliers.
అడగండి ఇక్కడ మీకోసం నన్ను ఎవరిని చూడలేదండి ఇక్కడ లోపల ఉంది కనీసం కావాలని అడగలేదు అంటే ఇక్కడ నుంచి ఈ హకథాన్ ఈవెంట్స్ అయితే తీసుకున్నాను
తీసుకొని
వాళ్ళని అడగండి మీకోసమే ఉన్నాయి ఇక్కడ
Hello. Okay, so how can we find outliers? Using box plot. Already we did earlier, right? So using box plot, you can find the outliers, right? And manually, how can you find? Okay, you can find with Q1 and you can find with Q3 and Q2, IQR. You can find by manually, right? In Excel, we have equals to quartile, right? Quartile include and quartile exclude we have, and quartile also we have. Okay. So there we have quartile and 25th percentile, 1, 2, 3. You can use And in Power BI also you can find Q1, Q2, Q3. Okay, there also we have quartile. Okay, so you can find anywhere quartiles. And here we are finding quartile 25th percentile. Seranya, fine. Yeah, I'm finding Q1 is equals to current price. Earlier we checked, right? In current price we have outliers. Few outliers we have. So for that, DF of that current price. Okay, DF 10 I copied, right? So DF 10 of that current price dot quantile, right? 25th quantile percentage is 25th quantile is Q1, right? 50th quantile is Q2 and 75 quantile is Q3. When you're describing your data, you can get Q1, Q2, Q3 directly, right? 25th percentile, 50 percentile and 75 percentile, and minimum value is 0 percentile and maximum value is 100 percentile. Right? So those values must and should you need to remember. How can you get 0 percentile and 100 percentile and 25 and 50 and 75 percentile means don't go with this dot quantile 0 0.00, 0 0.25, 0 0.75, 0 0.100. Okay, don't do that. Okay, you can do describe, you will get everything for numerical data. Okay, so you can do manually like this, or you can do descriptive statistics. Fine. You can do the descriptive statistics and you can assign Q1 is equal to, you see that one and assign Q1 is equal to 15.75, Q2 is equal to 25.75, Q3 is equal to 72.75. Like that you can assign Q1, Q2, Q3. Okay, and here also you can assign, you can find like this. Right, here I'm finding Q1 is equals to my current price of dot quantile 0.25 and Q3 is equal to 0.75. We know that. And Q2 is equals to 0.50. Right? You can apply and print Q1 and Q3. Fine. Next, IQR is equals to Q3 minus Q1. Right? I'm getting my output here. IQR. See, Q1 is 2180.75 and Q3 is 17121.75 and IQR is 14941. Right? 14941. And you can find Q2 even. Is this correct? Is this correct? Anyone? Print syntax. Correct? Huh? Find the mistake. Anyone online? Sure, madam. Print, simple print function. Mistake. नहीं दिख रहा है सच में where it is, my god. Now is it clear? Still नहीं दिख रहा. Find the error. Anyone online, offline? इतना सोच रहा है. Don't think big, no error is there. Okay? अच्छा? Fine. ఇంకా ఆలోచిస్తున్నారా? ఏంటి మేడం F-string మెథడ్ ప్రింట్ మెసేజ్ వాటికి సంబంధమే లేదు. Print A is equal to 5 top we use print A, that's it. We don't want to use F-string, we don't want to use message, we don't want to use format modular methods. Direct print variable, print variable, print variable. ఇంతేనా మాకు రాదు చదవలేదు సార్. Fine. Q3 minus Q1, I am getting Q2, Q1 and Q3 and IQR. Okay. Next, how can you find lower bound? Upper bound? I got lower bound, I got upper bound. So print LB comma 2B. So lower bound is minus 20,000 something and upper bound is 39,533. Okay, this is the way you can find the lower bound and upper bound you can find in your current price. Okay, I got my lower bound, upper bound. So finding lower values is equals to DF of current price okay, upper bound is equals to DF of so using OR operator you can find that, right? Lower one you are getting and upper one you are getting 1.5 times of IQR, and lower one less than greater than you are finding upper bound, and you are doing value counts. Okay, LB dot something value counts. I'm doing print. Next, will be value counts I'm printing. Yeah, 450 there is no lower values and higher values I have 35 true and 415 is false. Okay, so this is my lower values and upper values, lower bound values and upper bound values. So like this, I got my lower limit and upper limit, and outliers is equals to, how can you find? OR operator, right? Using OR operator, you can find your outliers. What is data of current price? List. $39,533 is upper bound. So which values are above 39,533? Those are all my outliers, right? I have 35 outliers. So this is my 35 outliers. How can you remove outliers? Using? How can you remove outliers? How can you remove outliers? You can replace the values even. Okay, you can replace or you can remove using tilt operator. Right? Tilt operator you can use to remove the outliers. Yesterday exam రాశారు pandas. Huh? Pandas exam రాశారా? So, ఇది pandas కదా? Hmm? మీరు మేడం ఎస్టర్డే మీరే రాసిన ఎగ్జామ్ pandas చూడలేదు చదవలేదు అంతేనా సింపుల్ గా వైవా 2 క్వశ్చన్లు అడగగానే చెప్పి తల ఊపిలో వెళ్ళిపోయాను right using tilt operator. So you can use this tilt operator to remove the outliers, right? So we'll go with outliers. df 11 is equals to df of this value right this removed from your data, right? If there is any outlier, it is removed from your data. So earlier I have only where it is value counts 415 unique values, sorry, 415 regular values and 35 outliers I have in my data and 450 zero values. Fine. So here those 35 values are these. Okay, these are all my 35 values. And here it is removed 1, 2, 3, 4, 5, 455, 445, 46, 47. So like this you can do. Fine. So I got only length is 415. So it means 35 outliers has removed. And now you can find the box plot sns dot box plot df. Okay, 11. You can do directly. Here. What is that? Oh, still it is showing one. What? DF of current price. Same thing we're using here. DF of we removed this one. Next we got 415 by 9 rows, 9 columns. Measure as box plot. DF of current price.
Sir, so we didn't make it, we did of this, we assigned
So DF, I assigned to DF. DF of current price only I'm doing here. LBUB I'm finding. DF of current price. I'm finding this one. And DF is equals to DF of this one I'm removing. I removed some outliers from my data. So 415 by 9 I got here. And SNS dot box plot of current price. Okay, still is showing outliers. Again, we find one dial Q1, P2, Q3. Q1, Q2, Q3. I got. You understand the problem, this one? Why still is showing outliers? After removing outliers also, still it is showing outliers. Okay? No, not different one. No. See here. I have my data frame. Okay, in that current price I'm using. Fine. I'm finding question the answer here. I'm finding Q1, Q2, Q3. I got my Q1, Q2, Q3. Okay. For this data, these are all my Q1, Q2, Q3. Okay. For only for this data. So I got my IQR here. I'm finding lower bound and upper bound. I got 20,230. I got 39,530. Okay. For this data, for this current price data, so these are all my lower bound and upper bound values. Okay, I got this much, and lower limit who are above lower limit and who are below. So limits I'm finding here. So 450 values. So there is no lower limit values. Okay, and
the first data sheet is only written DF. You are working on DF 10. You have to change here.
yeah, okay, fine. DF10. To 30 and DF10. I got 450 and 35. DF10. I have to remove. So I got 35 values here. And DF10 is equal to DF8. I got it is removed 35 rows from this column. And DF got described. DF got DF8. Same thing, right? So DF10 lower limit values. So who are below lower limit and who are above upper limit I'm finding here. Okay. I'm doing value counts and value counts I'm doing. I got these value counts. Okay. 415 is below lower bound, sorry, upper bound, and 35 is above upper bound. Okay. 35 is my outliers. Here 35 values is my outliers. Next, I'm finding that outliers using R operator, pipe symbol. Okay. So my DF10 current price of so lower bound values and upper bound values pipe symbol I'm using. So I got my 35 values display. Okay. So these are all my outliers. Next. So DF8. So some variable is equals to. So my data frame. I'm removing the outliers. Okay. Using tilde operator. LV and UV, upper bound and lower bound values. So I'm printing that one. I got 415 by 9. Okay. It is removed. 35 rows are removed. Right. Next. So I'm giving the descriptive statistics. The maximum one is 39,490. So our upper bound is 39,580 kind of thing. Okay. So it is below the upper bound. Right. I got this one. I'm giving the box plot for this. Okay. I'm giving the box plot for this. Still I'm getting outliers. See, my upper bound is 39,580. It's around 40,000. It is below the 40,000, right? 39,490. But it is showing as outlier. Okay. 35,000 also showing as outlier. 30,000 values also showing as outlier. Why means after removing the data, I got some data, 415 rows. So to apply 415 rows analysis, so for that 415 rows analysis, we have outliers for. Okay. For 415 rows, again we have outliers. Okay. So again, we need to find the Q1, Q2, Q3 and lower bound, upper bound, remove those things. Right? See here. Actually, 39,000 is below the upper bound. Right? Which one? This one. 30,000. Okay. Our first analysis is perfect. 39,000 is upper bound. We seen right here. The maximum value is 39,490. it is below the upper bound, but still it is showing as outlier 39,490.
Now, once again, can you scroll up? Can you add the column in above that?
Which one?
You can scroll up. Can you add after DF and the column in?
Here.
Yeah.
Only one line data only you can see here. Current wise. Okay. See, only one line you can see. Earlier I did for entire data frame. So entire data frame you can see. But here you can see only that one line. 415 rows again. DF8. Describe. So only single value. It is showing as value error. Could not interrupt input current price. There is no column. It is acting like series. It is created series. Okay. So that's why I'm taking entire data frame. Same thing. It is also gives 415 rows. See, 415 rows only. Just it removes from current price, entire row it removes. Fine. 415 rows only I got here. I'm printing that one here. So I got the entire data. Descriptive statistic given to dot SCRI. I got descriptive statistics. So the maximum one is 39,490. It is below the outlier upper bound, right? So, but still it is showing us as outlier. Okay. Again, for my data, it is treating outliers. Okay. Why? Because Apple products we have. Okay. Apple products have maximum price, and remaining Bolt, Boat, and Firebolt, different brands we have. So that is 1,000, 1,200, 900, 11, 1,500 to 2,000 in between. So for Apple, 20,000, 35,000, okay, 60,000, 50,000 kind of rates. One product is 85,990, right? So that is huge outlier. Okay. So compare with 1,000, 85,000. Compare with 1,000, 70,000. Compare with 1,000, 40,000 as outlier. Okay. So this is the way. Again, it is showing as outliers. Fine. After removing also again showing as outliers. So you can find outlier again. Okay. Now my upper bound is changed. It is coming to 30,739. Okay. It is coming to 30,739. And you can do this one. DF8. Okay, one. DF8. So 20 values I have. Okay. So bottom also have some values. So we do that one. So there is no bottom values and 20 values are my outliers here. Okay. So how can we remove? Using tilt operator. $395 is removed. So we'll check with one more time. DF. Continuously it is showing as outliers. So we have huge differences. So that's why it's showing as outliers. So if there is no differences, so it simply it removes that outliers. Suppose if you do with ratings, is there any outliers? We'll see. We'll go with ratings. Point five. Yeah. So I have 10 values. So continuously this range is changing. So we have different high range values. Guys, we have high range values. So in my data, so when I'm removing outliers from my data, so again it is changing. Suppose I have my data like this. Okay, I have like this. So from up to here it is maybe 39,000 it is showing, and these are all my outliers. Okay, after removing this data, it is okay. After removing this, again it is giving like this, and it is 30,000, and remaining data is up to 40,000. After removing these outliers, and again it is giving like this, it is 15,000, and it is up to 20,000. Okay, so up to where it is exactly you will get, so there it will stop. Okay, so here I have huge differences. Why? Because most of the brands having 1,000 to maybe 6,000 or 4,000 rupees. Okay, frequency, and only few brands having from 6,000 to 85,000. So that's why these are all acting like outliers. Fine. So when you're removing these things, so when you find this Q1, Q2 is 1,000 and 6,000, 5,000 kind of thing. then it will stop. Fine. So like this, we are getting outliers. So you can remove your outliers using tilt operator, and you can find your outliers using pipe symbol. Okay. So like this way, you can analyze your data. You can find your outliers. Fine. And remove outliers, and you can consider those things. So if they want to remove outliers, you can remove. Otherwise, you can go with outliers only. Fine. And what is your analysis and what is your observation? You have to do that things. Fine. So finding duplicates and dropping duplicates and adding new columns by insert which person you want to add and end you want to add, adding new columns and new rows and concatenation. Okay. Append has removed from pandas and series and data frames. So there is no append now. So concatenation we have. So you can concat your data. Fine. Group by, value counts, and this histograms and box plot and heat maps, correlation. Fine. And this line charts. So you can use any charts and you can perform your analysis and what your observation about the data you can find. Fine. So this is the way you can do your analysis. So not only this one. Okay. So try to load more data sets and first analyze the data set. Descriptive statistics. Okay. Read the descriptive statistics and which type of description they are giving. Okay. Which type of description model is giving. Fine. So what is the minimum value, maximum value, how we are finding outliers and how we are dealing those things. Okay. How many null values is there? Okay. You can find those things when you're practicing with different data sets. Okay. And one data set will give one type of descriptive statistics and another data set will give another type of, okay. Why? Because we have different types, right? So integer and float, those are all comes under numerical data and remaining things are object data, and how we are finding this descriptive statistics for numerical and objective data types. And after that, inferential data and finding memory. And next, adding new columns, adding new rows, and removing columns and removing rows, and LOC, ILOC, right? Data manipulation. And so this analysis, univariate and bivariate and multivariate analysis, and finding outliers. Okay. And these are all things you can perform. So this one only. So if they are giving any problem statements, you can go with the problem statements. Otherwise, this is normal analysis. Okay. So how you are observing about your data, what is your value counts and what is your group by? When you're doing group by, what is your analysis? Okay. Group by with average price, maximum price. Okay. And what is the difference between maximum price and average price? Okay. And minimum price. And what is the difference between minimum price and average price? Okay. You can find like that. Okay. What is the average ratings, average sum of sales, average profit? Okay. Sum of profits, sum of sales. So those are all things you can find with value counts and group by. Okay. Like this, you can do your analysis with pandas. Okay. With the help of pandas in Python. Okay. So any doubts regarding this? Creating bins, like creating label names, KD, lines, correlation, heat map, pair plot also you can do. Okay. Any doubts? Okay. So try to do more data sets. Okay. Try to analyze more data sets. Then only you will get confidence. Okay. About data sets. If someone giving data set, you can understand easily what can you do with the data sets. Okay. What could we do with the data sets? What is the first step and what is the second step? What is our analysis? Okay. These are all things you can find. Okay. 58 guys you can go for class. Class also 58. 68. Fine. Yeah. Any doubts? So next week, in this week, Monday to Saturday, we'll conduct a Power BI session in middle. Okay. And weekend also, one more session we have, again Power BI. Okay. 2 Power BI sessions like this.
Like during daytime, it will be
We'll see the time. Okay. Today I will give the data sets for you. Okay. What is your name? Om Prakash. Yeah, fine. So Om Prakash means Sahiti batch. Yeah. So every day she is asking, who is Om Prakash? I don't know. Who is Om Prakash? I don't know. Who is Praveen Prakash? I don't know. So maybe she is online, I think, today. No. Fine. Yeah. So this is the way you can find your analysis. Okay. Do more data sets, then you will get some clarity. Different methods and different things you can elaborate while practicing. Then you can understand a lot of things. So lot of methods and lot of methods we have in Pandas. You can go to cheat sheet. Pandas documentation. Okay, so this is hundreds of pages, thousands of pages we have. So lot of things. Okay, all models you have. Left side you have indexing, and right side you have data, group by, aggregation. Click on this. So you can see this one. Data frame, dot, group by, gender, and dot sum. Okay, aggregation. So for like that, for everything you have cheat sheet here. Missing data. Okay. Like this, you can go with Pandas cheat sheet. Complete Pandas documentation you have here. Okay. Left side you have index. So which one you want to find? You can select those options. Okay. Yeah. D types. So click on D types. You can see the data types of this one. See date time, categorical, period, type. Okay. These are all about D types. Okay. As type, converting one data type to another data type. In converting into integer. As type float. So everything will convert into float. As type integer, everything will convert into integer. Okay. Handling column names. You can change the column names. So here you have a lot of things. So you can go with the cheat sheet. And in this is Python documentation. These are all methods you have here. Okay, index insert. Pandas index. Okay, like this, you can see these things. It is loading. Loading it is. So here you have cheat sheet. Go with this one. Any doubts? Fine. So we'll meet with Power BI. Okay, in this weekday and weekend. Okay,
Sir.
who's completed Power BI? Those guys only can attend. Remaining people are not required. Fine.
So like Power BI also send EDA.
No. Complete Power BI will explain in 2 sessions. What is Power BI editor? What is Power BI desktop? And what is visualizations and which type of DAX we have? Okay, load the data set and
Sir.
create a dashboard and some changes. Okay, we'll discuss everything with Power BI. Okay, how it will be creating measure, creating column with the DAX. Okay, and new column, adding columns and removing rows and adding rows and merge queries and append queries. Okay, transpose, pivot, changing data types. Everything we'll see with in Power BI. Fine.
Sir,
Yeah, please.
do we have a lecture in the evening of Suresh, sir?
Yeah, you have Excel session evening. So for 69 batch.
No,
69?
no, for 67 batch.
Yeah, you have Excel session evening. No.
Statistic.
65, 66, 67.
Okay, sir.
You have Excel